everyone, I am Johnny, and welcome back to part 4 of this Paper Mario tutorial series. This time we're going to be making a hammer swing. This hammer swing, when we're done with it, will be very similar to Paper Mario the Origami King's hammer swing, but it might still be a little buggy, clipping into things every now and then, just because there isn't really a tutorial for this kind of thing on YouTube anywhere that I know of. So I'm basically working from scratch. I did the best I could, but it still may be a little buggy, but it works well enough. But before we get into it, I need everyone to do me a favor. I've been asking it a couple of times in the last couple of videos. I've been asking people to leave their comments of what they want to see next in this series in the comments. And so far, I've done 3 videos on it, and I haven't gotten a single one. So leave your ideas in the comments. I have a few ideas, but I am going to run out fairly soon. So be sure to leave a comment on which part of Paper Mario games you want to see me recreate in Unity. So first of all, to start off with getting the hammer in, we first need to have an actual hammer to swing. So in the description of this video, I'm going to have a download for this hammer, and it will have this material file with it, and you can drag those both into your project folder, and you should have this hammer here. And you're also going to need, if we go to sprites, we're going to need some sprites for Mario's hammer swing. So you can see here that I have these 12 sprites. It's to go through, it's basically 4 different directions that Mario is facing for hammer swings, and each of those 4 directions has 3 sprites, that being Mario's hands behind his head, in front of his face, and down low. And there's that also for diagonally, and also facing towards the camera and facing away from the camera. So make sure you have those 12 sprites somehow, or the corresponding sprites for your character. I'm not going to leave a download to Mario's sprites because of obvious reasons. And as long as you have those, we are good to get started. So the very first thing we're going to need to do is go up to the top left, click Edit, go to Project Settings, and we're going to want to go underneath Time. And you can see here there's this part here that says Fixed Time Step. We're going to want to change this from 0.02, which is the default value, to 0.005. The reason we're doing this is a bit complicated, so I'm going to quickly hand it over to post-commentary editor myself to explain why we're doing this. So if we look at Mario's hammer swing from Paper Mario the Origami King, we can see that it takes 1, 2, 3 frames for the hammer to be swung fully. And the issue with this is that Unity, by default, really does not like handling objects that are moving and rotating that fast as far as handling their collision. So the fixed time step interval that we changed from 0.02 to 0.005, well, we're basically increasing the number of times that the physics are calculated, and it's calculated for fixed update. So we've been using fixed update in previous videos. So if it was 0.02 before, it would run a certain number of times per second, but now that we've changed it to 0.005, it's 4 times smaller, which means it's going to be run 4 times as often as it used to be. So this will allow us to check for collisions when we're swinging a hammer a lot better. We're not even going to have a 3-frame hammer swing just because it would be really difficult to calculate. The other thing about changing this to a smaller interval is it means that some of the values we have for our running speed and our jump height are going to seem a lot smaller now if we were to start playing the program. So we're going to have to multiply those values by 4 because we made it calculate 4 times as much, so we need to increase them by 4. So the first thing we're going to do, now that we've changed the fixed time step to 4 times faster and also adjusted our values so that they work with that time step, we're going to create the scripts we're going to need to actually get a hammer swing working. So we can go into our scripts folder and we're going to add 2 new scripts. We're going to add a first one. This is going to be called hammer script. And we're going to create another one called hammer hit script. And the hammer script is going to handle the actual swing of the hammer, and the hammer hit script will handle when we actually hit something. And we'll later set it up so that if it hits something, it'll cause the appropriate behavior, like if we hit a block, it'll like release a coin, but that'll be for a later episode. We're also going to go into our Mario State Machine folder, and currently we have 8 scripts in here. We're going to add another one. We're going to add a C# script. This is going to be called Mario Hammer State. And we're going to quickly go into our Mario Hammer State scripts that we just created. I need to wait for it to load. And we're going to copy the example state script so that this can easily be made. So Control A, Control C, Control A, delete, Control V, and then we're gonna rename this to fit, so Mario Hammer State. Same thing here, Mario Hammer State. We're gonna save that, and we're also going to go to our Mario State Factory, and we're gonna add another one for Mario's Hammer State. So public Mario base state hammer return new Mario Hammer State context comma this, and in parentheses hammer. So now we're going to go into our Mario State Machine script, and we're going to add a couple things. So first of all, underneath the first variable, current state, we're going to add a public string current state name. And we're going to go down to the fixed update, and at the top of it we're going to say current state name is set to current state dot state name. And basically this will just give us a reference to what state we're currently in, and so we can get the name of what state we're currently in and we can use that for reference. Next thing we're going to do is we're going to add some more variables up here. So I'm going to add them right underneath ground check. We're going to add a public game object called input direction. This is going to be the direction that we input. Obviously, if we input upwards, we don't want Mario to hammer to the side, so we're going to use this as a reference as to which way we're facing. We're going to add a public bool called lock input direction, as this is basically once we start hammering, we don't want to be able to change the direction that we're hammering in. We want it to be locked in, and that's what that's for. We're gonna add a public, and this is gonna be hammer script. This is one of the scripts we just created. We're gonna call it hammer. We're gonna have a public bool finished swinging, and we're gonna have a public float called hammer angle. So finished swinging will be used to determine if we finish swinging the hammer, and hammer angle will be used to determine what animation Mario should go into based off of which direction he's pressing. So if he's pressing up, he should have the animation of swinging the hammer upwards instead of hammering to the side. So now we're going to create some actual objects in the scene that we're going to need to set up this hammer. So first we're going to right click on our player and we're going to click create empty, and we're going to rename this to input direction. And we are going to keep the transform mostly the same, but we're going to rotate it by -90 on the Y. And we technically don't have to do this because we're going to set the rotation of this through code later, but we always want this to be facing Mario's forward, or the direction that we're tilting. And we're also going to right click on this, and we're going to create another empty game object, and we're going to call this axis. And this is going to be offset a little. I have some numbers here that I know work for my particular thing, but this is going to line up roughly with Mario's shoulder. So I have -0.155 and Z -0.163, and as you can see, it's kind of at his shoulder. This is because when we're going to set up the hammer offset based off of this, and then we're just going to rotate this object. So we'll have the hammer be like right here, and then we'll just rotate this object, and the hammer will rotate around the top of Mario like a hammer swing. We're also going to duplicate this axis, and we're going to rename this to rotation object. Next, we're going to go to our assets, and we're going to take the hammer that we imported, and we're just going to drag it into the scene real quick. And we are going to quickly right click on it and go to prefab and unpack. And then we're going to want to take this default object inside and drag it out, and then we can get rid of the hammer object because we don't need that anymore. And this default we can actually rename to hammer, and it just has the mesh on it. Now we're going to drag this underneath axis, and we're going to adjust the values so that it's in the right position. So let's see here. For my values, I have 0.069 on the X, 0.521, and 0 on the Z. And then for the rotation should be 0, 0, and then -90. And this should be about a scale of 0.6. Oh, and I also forgot to rotate axis by 90 degrees on the Y. That's why it was facing the wrong direction. But now with these values, it's roughly the size the hammer should be, and it's relative to this axis point that we set up, and it's roughly here on Mario's, like the handle is roughly here, like kind of above his ear a little. So the reason we set all this up is because if we were to take this axis and rotate it on the Z axis, it creates the hammer swing animation. So we're going to set this up through code later, but this just makes it easier for the hammer swing to actually take place. Now, though, we can't really just use the collision of the model itself. For some reason, I just could not get it to work when I was doing this in practice. So we're going to do the next best thing. Instead of using the collision of the actual model, we're just going to use two cubes. We're going to use one for the head of the hammer and one for the handle of the hammer. So we're going to right click on our hammer and click create 3D object and cube, and we're going to name this head, and we're going to adjust the values of this. So this should be the same if you're using the same model and scale and whatnot. So this can be 1.813. That lines it up with the center of this of the hammer, or the center of the head of the hammer, and the scale should be 1.6 on the X. So now you can see that it basically takes up the area of the or the volume of the handle, or of the head of the hammer itself. It's a little bit off, so that there's like still these edges and whatnot, but it's pretty much the same. And we can also go ahead and get rid of the mesh filter and the mesh renderer because we don't need to see this hitbox. We just need the box collider on it. And we can also duplicate this, and we're going to rename this to handle. And we're going to adjust the values this. So this is going to be 0.5. So this brings it to the center of the handle, and we're going to change this to 0.2, 1.4, and 0.2. So now it's a thin but kind of long box that fits for the collision of the actual handle itself. So if I were to quickly turn off the mesh, we can kind of see that we have the head and the handle. There's a little bit of space in between. That's fine. We just don't want these two overlapping with each other because that could cause some problems. Then I'm going to turn that back on. The next thing we're going to do is we're going to go to our, let's see here, we're going to go to our hammer, and we're going to change the layer. We're going to click add layer, and we're going to add a new layer, and this is going to be called hammer, and it's going to be layer 6. So if we go to our hammer and then we now click the layer, we can change it to hammer, and click yes, change children. And the reason we're going to use this is we are going to make it so that this, because right now we have this, especially the handle is kind of going inside of our main collider right now, And we don't want there to be collisions between the hammer and Mario's collider. So we're going to do something in code to make it so that these two layers never interfere with each other. So we can go ahead and do that now. So now we can go into our Mario State Machine script, and underneath the current state name that we just set up, we're going to add physics.ignore layer collision, and then in parentheses we're going to say 3, because 3 is the number for the layer of our player, which is for our collider, and 6, which is for the hammer layer, and we're going to say true. So we're basically saying that if there's a collision between the player layer and the hammer layer, it's going to completely ignore it. And it's going to do this at all times. So now we're going to add some of the objects we're going to need to make the actual animation of the hammer swing for Mario, at least. The animation can't really be done through the traditional animator like we've done before, because it won't be accurate to where Mario actually swings his hammer. But by doing what we're about to do, it'll make sure that it's always accurate. So what we're going to do first is we're going to take our axis and we're going to copy it. And we're going to get rid of everything underneath it so we can get rid of the hammer. We just have the axis. The reason we need this is because we need it to be in the exact same spot. And we're going to rename this to side sprites. And we're going to drag this under our hammer. And it should have its variables change up here once you drag it under. That's normal. We're going to go ahead and duplicate this again, and we're going to rename this one to diagonal I can't spell diagonal sprites. We're going to rename it to diagonal sprites. So we have side sprites and diagonal sprites. And then we're going to put the side the sprites of Mario swinging his hammer to the side and swinging it up and diagonally underneath the appropriate objects here. But we're also going to duplicate this 2 more times. The first copy is going to be called up sprites, and the second one is going to be called back sprites. And actually change up sprites to forward sprites. It's a little more easier to understand that way. Up sprites is a little confusing. And we're going to take both forward sprites and back sprites, and we're going to drag them underneath not axis. We're going to drag them underneath input direction. So they should be, the cube next to them should be lined up with rotation object. And now what we're going to do is we're going to drag, so let's go to our side sprites first, and then we can find our side hammer swing. So for me, it's this sprite, and this sprite right here. And we're going to take the first one, so mine is called 45, and drag it underneath side sprites, and it's going to create a sprite here. And I'm going to go ahead and zero out everything on it. So now it's at more of a regular height, but it still isn't in the right position. So to make this a little easier, I'm going to quickly turn off the animator so we don't have to look at the idle pose right now. And I'm going to take the sprite that I just dragged in. It's labeled 45, but I'm just going to call this side 1. And I'm going to move it around until it's in the right spot for where Mario would be holding his hammer. So for me, I'm going to have to drag it up a little, and I'm actually going to rotate it a little on the z-axis. So I think that's good. And let's move it a little over. So that looks about good. It's kind of in his hands, roughly, where it should be. And the nice thing about this is that when we go to rotate our axis later, because we're going to rotate our axis later to actually get the hammer swing to happen, when we rotate it, this sprite will rotate with it. And so it's always in Mario's hands no matter where it rotates to. Now we're not going to let it rotate all the way while he's in this pose. So what we're going to do is we're going to also drag in the next two sprites. So there's also this one, which is the second sprite, and this, I'm going to call it side 2. I'm going to quickly turn off side 1 so it's not in the way. And I can bring side 2 back to normal, and then I can rotate it so that it matches where Mario's hand should be. And I can even move it a little bit if I need. I think I'm going to move it a little bit this way. And now when we go to rotate axis for like the second part of the animation, it's in his hands and it's for this sprite. And it's rotated now, but it will look correct when we actually do the hammer swing due to some code we're going to add later. And last but not least, I'm going to add this last sprite, which for me is called 49. Call it side 3. And I can reset it and then rotate it. I think this is -180. Should be upside down, which looks a little strange, but it'll work. And we're going to move it a little bit to the side, maybe actually a little bit down. And this will also rotate when we rotate axis, so when we get to this part, it'll look like he's holding it normally. So I can revert that, and I can turn off, I'm going to turn off all 3 of the sides, and I'm going to go ahead, and what I was just doing where I position them and rotate them so that Mario's hands are holding the hammer, I'm going to do that, the same thing, for diagonal sprites, and I will come back for forward sprites and back sprites because they are a little bit different. But I'm just going to quickly do the same thing I did for side sprites, but for diagonal sprites with the different sprites. I'll be right back. So now I've gone ahead and added the side sprites and the diagonal sprites, and you can see that they line up with where Mario would be holding the hammer. And now we're going to do the same thing for forward and back sprites, but first we're going to go to both of them and reset their Y rotation to 0. So now they should be facing to the left. And we're just going to do the same thing. So for forward sprites, forward is facing forward, so that would be this one. I have it labeled as 52. Now, you're going to notice that it's facing the same way as it normally does. But we actually don't want this. We want to reset the actual sprite's rotation. So set it to 0, and this will rotate him in what looks like a weird way, but if you think about it, this input direction, which this sprite is following, because it's a child of, is only going to show the forward facing if this turns to face forward, and then in that case the sprite would be facing towards the camera. So it looks a little weird now, but it'll make sense. Anyways, reset the you can reset the rotation and the position, and you'll have to adjust it according to the hammer. And I'm actually going to make it a little bit, have the hammer be a little bit lower than his hands, because you won't really see his hands that much, and that way when it swings up, it actually looks like it's in his hands. So I'm going to move it a little lower, and I can rename this to side 1, and I'm going to do the same thing for the next two sprites, so it's going to want to set it to normal, but we don't want that. And I'm going to go ahead and turn off side one so I can see what I'm doing a little better. And this one, for these sprites, the forward and the back sprites, you don't actually really need to rotate Mario, because this sprite isn't actually going to rotate. It's just going to change as you swing the hammer. So I'm going to make sure this is at about the same foot height as the other one. So I can move this up a little bit. And that looks about good. And I can rename this to side 2. And last but not least, I can add this last forward sprite. Again, reset the rotation and position. And from there, you can adjust it so that his feet line up. So mine needs to be moved a little to the side and a little bit up. And that looks good. So now we can rename this to side 3, and then we can turn all of these off. And I am going to quickly do the same thing that I just did for forward sprites, but for backward sprites with the ones where he's facing the camera. And with these ones, you may want to make sure that his hammer actually kind of lines up with his hands. But I'll be back once I finish doing the same thing with these sprites. So I have finished doing the forward and back sprites, and I just want to show you for the back sprites where he's facing towards the camera. You can see that it looks kind of weird from this side. It kind of looks like he's the hammer is sticking out of his nose, but that's because we're not actually going to see this side when he does the hammer swing. We're going to see this side, and from here it actually looks like he's holding the hammer behind his back. So if it looks a little weird when you're setting it up, that's fine. It's all a matter of what we see and what we don't see. So now I can turn off all those individual sprites, but we can keep the parents, like the side sprites, diagonal sprites, forward sprites, and back sprites. We can keep those turned on. And now we're going to get into the actual scripting of getting this hammer swing working. So I'll get to that. So now we're in the hammer script that we set up. And we're going to start by changing update to fixed update, because obviously the things we did earlier would be pointless if we didn't actually use fixed update. And now we're going to add some variables that we're going to need. So the first thing we're going to need is a public bool start swing. So basically when this becomes true, we're going to start the hammer swing. We're going to say public game object axis, public game object hammer, and these are going to be the respective objects within the scene. We're going to have a public rigid body called RB, and we're going to set this up later. We're going to have a public game object rotation object. We set that up earlier. We're going to have a public float force. This is going to be how much force is applied for swinging the hammer, so how fast it's going to turn. We're going to have a public float angular max. We're going to be using something called rigid body, and rigid bodies by default have a limit on how fast they can rotate or how much angular velocity they can have. So we're going to have a variable for that, and we're going to actually change the value of that so that it can swing faster than the max will allow normally. Next, we're going to have a public bool swinging, and this is going to be true if we're swinging the hammer. We're going to have a public animator called anim, and this is going to be a reference to Mario's actual animator. we're going to have a public player state, I'm sorry, we're going to have a public Mario state machine. And this is going to be called machine. And below this, we're also going to have 4 game object arrays. So if you don't know what an array is, you can type out, for example, I'm just going to do the first one, a public game object. I'm going to call this side sprites. But obviously side sprites, as we set up, there's 3 different sprites. And we want to be able to turn on one at a time. And normally we'd have to write out 3 different game objects for that, 1, 2, and 3. But instead we can do an array. So we do public game object, and after the word game object, we're going to do brackets. And that's an array. And this will let us put in multiple items. So it's kind of like a list of items. So we're going to have a public game object array side sprites, a public game object array diagonal sprites. We're going to have a public game object array called forward sprites, and a public game object array called back sprites. Now let's go over to start. The only thing we need to put here is we're going to say rb.angularVelocity is set to angular max. So as I said, there's a limit on how much force can be applied in a oh wait, I'm getting an error. So, I typed that wrong. It should actually be rb.max angular velocity is set to angular max. So as I said earlier, there's a limit on how fast things can turn by default, and we're going to change that so it can turn a little faster. Next, we're going to go down to fixed update, and we're going to say if start swing, so if we get the instruction to actually start the hammer swing, we're going to set swinging to true because we're swinging the hammer now. We're going to say hammer, so this is the hammer object in the scene, dot set active, and then in parentheses we're going to say true, and we're going to say start coroutine, and in parentheses we're going to say rotate hammer. And we don't have this set up yet, but we're going to set this up in a little bit. So rotate hammer and then parentheses, and it's going to give us an error, but that'll be fixed soon. And we're going to set start swing is set equal to false. So it's going to be set to true, and then these things will happen, and then it'll be set to false, so it doesn't happen twice. After this if statement, we're going to say collision, or sorry, we're going to say axis dot transform dot position is set to rotation object dot transform dot position, and we're going to say if axis dot transform dot Euler angles dot z is greater than 180, and then we're going to say or, which is the 2 vertical lines, or axis dot transform dot Euler angles dot z is less than -90, and then we're going to go back to where it says if, and we're going to add an extra parentheses, and after this parentheses at the end we're going to say and, that's 2 and symbols, and swinging, and then parentheses, and then brackets. So basically what we're saying here is if the axis, which when it's rotated 180, it starts out at 0 degrees and then it rotates to 180 degrees for the hammer swing. So this is checking if it's greater than that, so if it's gone farther than a full hammer swing, or if it's behind where it should be, then we're going to say start coroutine reset hammer. And this is going to bring it back to the default position so that we can swing the hammer again when we want to. Next, let's set up this rotate hammer coroutine that we called earlier. So we're going to say IEnumerator rotate hammer, and then parentheses. Now, I don't know if I've explained what these are before, but this is a coroutine. It's not a function. Coroutines are a little bit different than functions, but they can run, they're not specifically called once. They can keep running for a while, and we're going to use that to our advantage. So we're going to say int I is set equal to 0. And we're going to say while, and then in parentheses, we're going to say I is less than 1. We're going to say RB dot add relative torque. And we're going to say in parentheses new vector 3. And then in parentheses, we're going to say 0, 0, force. And then outside of one of these parentheses, we're going to say comma, and we're going to say force mode dot force. So what this is doing is we're going to, I know it's a little weird that we say I is set to 0 and then we say while it's less than 1, and then we're going to say I plus plus after this. I forgot to say that. So it seems weird because this is only going to be run once. And we're doing a while statement, which we wouldn't normally have to do. But this is just to make sure that everything keeps running, because we're going to have some stuff after this that we want to keep running, even if we've already added force to rotate the hammer. So rb.addRelativeTorque is going to add a rotational force, which we set to be 0 on all axes except for the z-axis, which is what we need to rotate the hammer on, and we're going to rotate it by force, which we'll set later. And force mode.force is just a way of actually applying the force. There's a couple different ways, but force is pretty simple and works pretty well. After I++, we're going to say yield return null. And that should clear up a lot of the errors that we were having. Below this, we're going to say if machine.hammerAngle is less than 20, we're going to say start coroutine, and we're going to say change sprites, and then parentheses. And then in these parentheses, we're going to say forward sprites, and then a semicolon. So we haven't set up the change sprites coroutine yet. We're going to set that up shortly. This is just while we're swinging the hammer, it's going to change the sprite to the appropriate sprite for Mario's hammer swing animation. And we're going to have this function called with different sprites. So in this case, I called it with forward sprites because hammer angle being less than 20 would mean that we're pressing really far forward or upwards, and so the sprites should be Mario's forward sprites. Underneath this, we're going to say else if, and in parentheses, we're going to say machine.hammerAngle is greater than or equal to 20, and machine.hammerAngle is less than 75. And we're going to copy this statement from before with start coroutine change sprites and paste it, but we're going to change it from forward sprites to diagonal sprites. So this is if we're not pressing all the way up, but we're pressing more like diagonally upwards, then it's going to do the diagonal sprites. I think you can kind of see what we're doing with this based off of the angle. After this, we're going to say else if machine.hammerAngle is greater than or equal to 75 and machine.hammerAngle machine.hammerAngle is less than 160. Then we're going to do the same statement as before, but this time it's going to be side sprites. So this is if we're pressing more to the side and maybe even a little bit down. And then below this we're going to say else if machine.hammerAngle is greater than or equal to 160. So this is if we're basically pressing straight down, then Mario will face towards the camera and do a hammer swing. And so this one will be, back sprites. And now we're getting a bunch of errors because we don't have this function set up. So let's go ahead and set that up now. So below this we can say another IEnumerator, and we're going to call this change sprites. And then parentheses, and in these parentheses we're going to say game object array, so the brackets, and then we're going to call it sprites. So this is going to take in a game object array, which is what we put in when we put forward sprites, diagonal sprites, side sprites, and back sprites. Remember, these are game object arrays from all the way up here. So it's going to take it in, and we're just going to use that to change the sprites for the animation. So we're going to say while, and then in parentheses, not, so that's a exclamation point, not machine dot finish swinging, and machine dot current state name is equal to two equal signs to, in parentheses, hammer. So basically this is saying while the state machine that is running all of our main code thinks we're still swinging our hammer, and the current state name is, or the current state we're in is Mario's hammer state, because we'll know that based off the current state name. So while those conditions are met, we're going to say if if axis dot transform dot local Euler angles dot z is less than 45, then we're going to say sprites, and then in brackets we're going to say 0 dot set active, and then we're going to say true in parentheses. And we're going to go ahead and copy and paste this 2 more times, but we're going to change it to sprites 1 and sprites 2 for the second and third one. And we're going to change the values to both be false. So to quickly explain what's going on here, with a game object array, it's a list of multiple objects. So by putting a number in the brackets, we're basically we're basically finding an exact game object within the list. So 0 is the first one, 1 is the second one, and 2 would be the third one. It goes in order. And so if our angle is less than 45, so if we've only just started swinging the hammer, the first sprite of the hammer swing animation is going to be set to true, and the others are going to be set to false. So we'll see the first sprite of Mario's hammer swing and not the others. Next, we're going to say else if axis.transform.local Euler angles dot z is greater than or equal to 45, and axis.transform.local Euler angles dot z is less than 140, then we're going to copy these 3 lines of code from before, but we're going to change the values. So the first one is going to be false, and the second one is going to be changed to true. So basically, this is once we get past the beginning part of the, so when we go through the beginning part of the hammer swing, it's going to set the first sprite to be enabled because it's true. And then when we get to the later part, like the middle section of the hammer swing, we're going to turn off the first sprite and turn on the second one. So this is based off of our angle, and that will determine which sprite we set to be shown. And after this, we're going to say else if axis.transform.local Euler angles.z is greater than or equal to 140, and we're going to copy paste these 3 lines again, and we're going to change the first one to be, the first 2 are going to be false, and the third one is going to be true. So once we get to the end of the animation, the third sprite will appear. And underneath this, we're going to say yield return null, and below the while statement, we're going to say sprites 0, or actually we can just copy paste the same thing again, but this time we're going to set them all to false. So basically, this will keep running until we get to the end of the hammer swing, because we're checking if we're still swinging or not. And once it's done swinging, it'll run these lines of code, which basically turn off all the sprites, because we don't need to see the hammer sprites anymore after that. Next, let's set up this reset hammer function that we called earlier. So let's go down to the bottom, and we're going to say public IEnumerator reset hammer, in parentheses, and here we're going to do some complicated stuff. Reset hammer is going to be called whenever we finish the hammer swing, so when we actually hit something, or when we have swung the hammer all the way without hitting anything. So we're going to say float position is set to axis.transform.local Euler angles.z. So this is how far we rotated on the z-axis for the whole swing. And we're going to say position is set equal to mathf.clamp, and then in parentheses we're going to say position, comma, 0, 180. So what this is doing is it'll take the rotation on the z-axis, and if it's for some reason is lower than 0 or higher than 180, it'll bring it up to the minimum or down to the maximum so that it's within the range of 0 and 180. And then we're going to say position is divided equal to 180. So divided equal is the slash and then equal. What that means is we're going to set position is equal to itself divided by 180. So if it was 0, then 0 divided by 180 is 0. And if it was 180, it would be 1. And all the values in between will result in some decimal between 0 and 1. So this gives us a point between 0 and 1, and this will be useful. From here, we're going to say swinging is set equal to false because we finished swinging the hammer. And we're going to say float I is set equal to 0. And below this, we're going to say while, and we're going to say I is less than 1. Again, this is kind of a weird thing to say because it'll only be run once, but it's just to make sure everything keeps running afterwards. And in here, we're going to say rb.sleep. So we're going to tell the rigid body to sleep for 1 frame. What that means is it's going to lose all of its velocity for 1 frame. And this will be called when we hit something. So this will, if it's still rotating when it hits something, it will stop rotating. And we're basically just going to completely hold the hammer still so that it stays in place. And we're going to say rb.reset inertia tensor. This is basically just making sure that the hammer does not move. We're going to do some more stuff like this. We're going to say rb.velocity is set to vector3.0, and we're going to do the same thing, but for rb.angular velocity is set to vector3.0. And we're going to say I is plus equal to time.delta time. So I actually lied. I didn't realize I was lying. This is not going to only be called once. This is going to be called, I is going to be set to 0, and then as we keep doing this, I is going to be increased by however many seconds it's been. So it's time.delta time is the time in seconds between the last frame and now. And so basically, once we've gotten to 1 second of this being repeated over and over again, it'll finally break out of the loop. So this is basically to make Mario hold the hammer in place for 1 second once he's actually hit something. After this, we're going to say hammer dot set active false. So after this, we can make the hammer disappear. We made it appear when we first started, so when we first started swinging, we made the hammer appear. It's just for the visuals. And then here we're going to turn it off, and underneath this we're going to say axis.transform.position is set to rotation object.transform.position, and we're going to do the same thing, axis.transform, but this time rotation is set to rotation object.transform.rotation. And we're going to say rb.sleep again, and we're going to finally say machine.finish swinging is set to true. So basically, a lot of this stuff at the end here is just to make sure one final time that the hammer isn't rotating anymore once we've actually finished swinging, because sometimes it'll do some weird things once we set it back to the original position. So we set it to sleep again, and I'm getting an error still, and that's because I forgot to put after this I is plus equal to time.delta time, I need to say yield return null. And now we can go ahead and save this, and we can move on to our next script. So after recording this last clip, I realized that these 3 lines at the top regarding the position variable are actually unnecessary. So sorry for wasting some time on that, but we actually don't need that. That was for some previous coding that I did that didn't really work out, where I thought I needed that variable, but I don't actually need it for this particular hammer swing. Thanks for listening. So next, we're going to set up our hammer hit script, And this one is actually going to be very short. We can, first of all, we can get rid of update and start because we don't need either of them. And we're going to say public hammer script hammer. This is a reference to the hammer script that we set up just a minute ago. And we're going to say, we're going to start typing on collision enter. And then you can press enter and it should finish it for you. On collision enter is called by a collider whenever it collides with something. So we're going to put this on our collider objects, and then whenever they hit something, it'll call this function. So whenever we hit something, i.e. whenever we hit something with our hammer, and we've actually bumped into something and we want to register that we actually hit something with our hammer, we're going to say start coroutine, and then in parentheses we're going to say hammer dot reset hammer, parentheses, and then x, and then semicolon. And then for now, we technically don't have to do this part, but just as a way of showing that it does actually work, we're going to say debug.log, and we're going to say collision.collider.name. So this will give us the name of the object that we hit in our scene. And in a later episode, I'll actually set up interactions with different objects depending on, like, if we hit it with our hammer. So like maybe I'll have a block pop out a coin or something like that. But for now, this is just going to log out whatever we hit, and then later we can add all the special stuff like blocks and stuff. So now we're going to go to our Mario state machine yet again. And I should have added some stuff earlier, but I didn't want to add it quite yet because it wouldn't have made sense yet. So we set up an input direction game object within our scene, and our hammer is a child of it. So that means if the input direction rotates, so will the hammer. So we're going to basically set our input direction game object to follow our stick movement. So if we turn a certain direction, it will rotate with it. So below current state.update state, I'm going to say relative input vector 3, or I'm sorry, my bad. Below relative input vector 3, we're going to say if not, so exclamation mark, lock input direction. Then in here we're going to say if input vector 3 is not equal to vector 3.0. So if the input we're pressing on our control stick is anything but completely neutral, so if we're pressing the stick in a certain direction, we're going to say input direction dot transform dot forward is set to relative input vector 3. And then below this we're going to say else, and then in here we're going to say if in up facing state, so if we're facing upwards, we're going to say input direction dot transform dot forward is set equal to negative anim dot transform dot right. Dot right, and then plus, and then in parentheses we're going to say transform dot forward times 0.3f. So basically we're saying if we press a direction, we're going to want the input direction, which our hammer follows, to be whichever direction we press. But if we're not pressing anything, we want it to be the direction that Mario is facing, not just some random direction that it was left in. So if we're not pressing anything and he's facing upwards, we want it to be set to negative anim.transform.right is basically which direction Mario is facing, and then we're adding transform.forward, which will basically be the forward in the world, so it kind of angles it up into the side instead of just directly to the side. And then below this we're going to say else. So if we're not in an up facing state, so if we're just facing to the side, it'll be input direction dot transform dot forward is set equal to negative anim dot transform dot right. So it's basically the same thing before, but just without the forward part. And next we can move to the Mario hammer state, because I haven't actually set this up yet. So if we go to this, we want to, as soon as we enter the hammer state, so on enter state, we're going to say ctx.ground velocity is set to vector3.0, and we're going to say ctx.jump velocity is set to vector3.0. So basically, once we hammer, we want to halt all of our movement because Mario shouldn't be moving while he's swinging his hammer. And then we're going to say ctx.anim.play, and we're going to say, in parentheses, invisible. Now, this is an animation that I haven't actually set up yet, so I'm going to do that very shortly. But this is basically going to make the animator invisible, because we have all those different sprite objects that we set to rotate with the hammer. We're basically going to turn off the regular animator and turn on those individual sprites. And then when we finish the swing, we'll go back to just the regular animator. So invisible, and then on the layer 1. And then here we're going to say ctx.hammer.startSwing is set to true. So it's going to start swinging the hammer. And then on update state, we're going to call check switch states. And then in check switch states, we're going to say if ctx.finished swinging, so if we finished swinging the hammer and we're in the hammer state, we're going to say ctx.finished swinging is set to false, so it will only call this once. And then we're going to say ctx.lock input direction is set to false. And we're going to say switch state to factory.idle. And we can go ahead and save this. And last but not least, we're going to go into the idle and running states, because those are the states where Mario can do a hammer swing from. And we're going to go in each of them to the bpress function. So we set up an apress function and we use that to jump. The bpress function will be used to hammer. So I'm in the running state right now. So if we press B, we want to say, ctx.lock input direction is set to true. So this is going to mean, so the whole lock input direction thing is, once we press B, we don't want to be able to suddenly change, like during the swing, which direction the hammer is facing. We want it to be locked. So we're setting it to true as soon as we press the B button, so that it can't rotate the hammer, aside from the regular swing. And we're going to say ctx.hammerAngle is set to vector3.angle, and then in parentheses, we're going to say ctx.inputDirection.transform.forward, comma, ctx.transform.forward. So this is going to give us, so input direction is basically the direction that Mario's hammer is currently going to swing when we actually go to swing the hammer. And ctx.transform.forward is forward relative to Mario. So it's basically giving the angle between those two, and so if we're facing upwards, completely forward, it'll be an angle of 0, and if we're going, if we're pressing up, it's going to be 0, and if we're pressing down, it's going to be 180, and everywhere in between. And this is what we used in our hammer script for if hammer angle is in certain values to determine which animation we should be using. So we set it here, and then it uses it in the hammer script. And then we're going to say ctx.finishSwinging is set to false, because we just started, so we don't want it to immediately finish because it thinks finish swing is true. And then we're going to say switch state to factory.hammer, which we just set up. And then we're going to go ahead and copy this these 4 lines and go to our Mario idle state and paste them in the bpress function. And we can go ahead and save both of those. And now let's go back into the Unity editor and apply everything where it needs to be, and then we can finally get to our actual hammer swing in game. So now we're going to set up that invisible animation that that we put in the script earlier. So we're going to go to our animator and go to the animation tab, and we're going to click create new clip, and we can go to our animations folder, and we'll call this invisible. And this is going to be the easiest animation of our lives. We can hit the record button, and we can go to our animator object and go to the sprite renderer and go to the sprite, and we're going to change this to none. So no sprite selected. And then we can uncheck the red icon, and this basically makes there be no sprite, which makes Mario appear invisible. Now we can go into our animator, and you can see that it already added it in turns, but we don't want it in the turns layer, so I'll get rid of that. We're going to go to the animations layer and create a new state, and we're going to call this invisible. Make sure it's spelled the same way that we spelled it in the script. And we're going to give it an animation of invisible. And we're going to want to go to our actual animations folder and go to the invisible animation and turn off loop time, because we don't want this to loop. And now we can go ahead, and I'm going to quickly go to the animation tab and change to a different animation just so that Mario actually appears, but don't actually change anything about the animation. Next we can go to our, let's see here, we can go to our axis, and let's add, first of all we can go to our scripts, and on the axis we can add the hammer script and the hammer hit script. And let's go ahead and fill in the values for these. So start swing, you can leave that as is. Axis is going to be axis, we can drag that in. Hammer will be hammer. Rigid body, we haven't set that up yet, so let's go to add component, and we're going to type in rigid body. And let's set this up first. So mass can be 1, that's fine. We can change the angular drag to be 0, because that will be a problem, because angular drag will affect the rotation, and we don't want that. We can turn off use gravity, we don't need that. And we can go to collision detection and change it to continuous. And we can go to the constraints and freeze the rotation on the X and Y because we only need the hammer to rotate on the Z axis. And then we can go back up to our hammer script, and for RB we can drag in our rigid body. For rotation object, we can drag in this rotation object that we set up earlier. Force, I'm just going to play with the numbers right now because I'm not 100% sure, because I made some tweaks between actually coding this and then recording it. But we can go with 300, and the angular max can be about 40. Swinging we can leave the same. Anim will be the animator for Mario. Machine will be our player game object, because that has the Mario State Machine attached to it. And then for each of these four, you can see that it's kind of different than a regular game object. We can actually add elements. So I'm going to go to each of these numbers next to them, and I'm going to type in 3 on each of them. This is basically how many items within the list there actually are. So now you can see there's a list of 3 game objects. So this is side sprites, so we're going to go down to our side sprites, and we can drag in side 1, side 2, and side 3. And then diagonal sprites, we can go to our diagonal sprites, drag in side 1, side 2, and side 3. And then we can go to our forward sprites, drag in side 1, side 2, and side 3. And last but not least, the back sprites, we can drag in the appropriate sprites, 1, 2, and 3. And now let's go to our hammer hit script here. We only need to drag in the hammer script itself into the hammer hit script component here. And next we can actually go ahead, and I believe we need to fill in some variables on the player. Let's see here. Yes, so we can go ahead and drag in input direction for the input direction on the Mario State Machine. We can go to, for the hammer, we can drag in our axis, and the rest of it should be good. So now, just as a test, I'm going to turn off hammer because we don't need to actually see the hammer. And then I'm going to hit play, and as long as I've filled in all the variables, and I may very well have forgotten something, I should be able to press B and swing the hammer. And I'm getting some problems already. So I'm not sure what I did, but I'm going to quickly figure out what it is I did wrong, and then I will get back to you guys. So I believe I found what the error was. You can see that my axis is, the forward direction is facing that way, and my rotation object forward is facing this way. And when I finish swinging the hammer, I set axis's rotation to be the rotation object rotation, which ends up rotating it by 90 degrees, which is why everything was sideways. So we can just change rotation object to have 90 on the y axis for rotation. And now if we hit play, we should be able to hammer without any problems. So we can see that it works once, it works twice. We can hammer in different directions. And you can see that Mario even rotates depending on the angle. And if we press down, he does the forward facing, he does like the backwards facing sprites, and then forward facing sprites if he presses up. And right now he only has ground to hit, but if we go ahead and outside of all of this player stuff, if I just go ahead and add a cube, let's call this we'll call this just object, I guess, And let me move it over and down a little, and actually let me go ahead and give it a material so that we can see it a little better. Maybe scale it up, so 3 by 3, and maybe 2, and then we can bring it over a little, and let's give it the ground tag so that we could actually stand on it. And I forgot to actually disable the hammer again. We don't need to have that enabled at the start. If I go ahead and hit play now, we can see that because I gave it the ground tag, I can stand on it and jump off of it like it was a platform or something. But if I go ahead and hit it with my hammer, the hammer stops at whenever it hits the whenever it actually hits the object. And sometimes it will kind of like clip through, sometimes a little. I think part of that is because of lag, and sometimes the physics engine just miscalculates a little bit. It also doesn't help that I'm recording, which kind of slows everything down. But if I wasn't recording, this would pretty much never be clipping into the object at all. And depending on the different angles, you can see that Mario rotates as such. And this also works from the front, if I can aim it correctly. I think I got a weird animation thing, but I'll fix that later. And it works from the back as well, and from any side, really. So the hammer is a bit slow compared to some of the other Paper Mario games, but it does work, and we can add behavior for when it hits something in a later episode. But there we go, we have now successfully recreated Paper Mario's hammer in Unity. So I'm going to leave it up to you guys what you guys want to see next. I have a couple ideas of what to add, but again, this is a tutorial for you guys, so be sure to leave your comments, I haven't seen any yet, of what you actually want me to see me cover in this series, of what Paper Mario aspects you want to see me cover, and I will gladly try to recreate them in Unity. But other than that, I've covered everything, so thank you so much for watching, and I will see you in the next video. See ya!